Okay, so welcome everybody. My name is Mareike Petersen. I'm currently serving as the chair of the subcommittee Outreach and Communication of the Biodiversity Information Standards TDWG group, and I'm the moderator of this webinar, along with my TDWG colleagues, which is Deborah Paul, but you heard already that her connection is quite unstable today, but also Thierry, our current secretary, will help out today. In our webinar today, the topic is bioschemas, marking up biodiversity websites to improve data discovery and web scale integration. So we would like to welcome our presenter, Franck Michel, from the University of Côte d'Azur, and the National Center for Scientific Research, as well as the National Institute for Research in Computer Science and Automation, Inria. So, Frank, please share your screen.
Yes, I'm doing that right now. Okay, can you see my screen?
Yes, thanks.
Okay. Okay, perfect. So thank you, Mark, for the introduction. And well, first of all, I would like to thank TDWG for organizing this webinar. Basically, the topic of this webinar is something I presented already back in October at the TDWG 2020 conference. And there were quite a lot of questions at that time. So it felt a bit frustrating not to be able to continue and interact with the people. So hence, there was this idea of trying a longer format to be able to get into a bit of more details. Okay, so maybe just for a start, I will try to illustrate what we mean when we talk about marking up web pages, in case that's not necessarily clear for everybody. So imagine you're going to IMDb website or any other website you're fond of about movies or music or whatever. You can get access to such a page, like in that case, I looked up In the Mood for Love, and I will get some different information about the movie. So this looks like just a normal web page meant for humans, I mean. But if you actually open the code of the web page, look at the code directly, you will see that there is a piece of information that is not HTML. It's coded into a script tag, and the type is JSON LD. And what's in there is what we call markup. So it's some information that describes what's in the web page, but it describes it in a way that makes it interpretable by machine. So unlike the web page, which is meant for humans, that piece of script is meant for machines, for applications. So what's the point of doing that? Well, it's to allow consumers to develop smart applications that will exploit this information instead of just having humans being able to read the page. So now, if you Google the same, well, yeah, just to connect the dots here, you see that there is this information about the director of that movie, Wong Kar-wai here, and you will find this information in a different format here, written in JSON LD. So you have a director with a type person, a URL, and name. So those terms are something that is standard, and I will describe in a minute what it is. So if you Google In the Mood for Love, you will get a result page like this one. The results consist of different information. Usually you have a summary, but you may have additional structured things. That is, if you look at the result for IMDb, you can see that there is the title and summary, but also the director, the release date, language, ratings. These are not just words, random words added by Google like that. So then it is presented in a way that makes sense, okay? And the reason they can display it this way in a structured manner is because they have consumed that markup data, which is in the web page, and that allows them to better understand what's the content of that page and what is the connection between the things that are described on the page. And markup data is what fuels what they call, in the case of Google, the Google Knowledge Graph. Well, it's not the only thing, but it's one of the things that fuel this kind of knowledge graph that they build to have some sort of knowledge of the whole world, or at least whatever is on the web. And this knowledge graph is what is exploited at the time they create the right part of this page, which is what they call the rich snippet. So it's some sort of identity card of a movie that will give you lots of different information. But again, this is not just text that has been pasted here randomly. It's really taken from structured knowledge extracted from different sources, and in particular from the markup data that is in the web pages. Okay, so now markup data can be added within a web page in different forms, in different ways. One of the most prominent ones today is schema.org. So initially, schema.org is a community project, collaborative project. It's been funded by 4 companies initially: Bing, Google, Yahoo, and Yandex. Yandex is a Russian-speaking search engine. And the point of schema.org is to define a common vocabulary that makes it possible to mark up resources on the internet. So I insist here, this is on the internet, not just the web. So most of the time we talk about schema.org to annotate web pages, but technically you could annotate emails or any kind of other resource that you exchange in one way or another on the internet. So basically, it describes a vocabulary that provide structured data to describe the resources and make them understandable to search engines. Of course, their primary goal is search engines, and we'll see that's not the only goal that we can foresee now. But and what they use that for is to improve the ranking, because they understand better what's in the page, to improve. Well, for the web designers, it is a way to improve the discoverability of their web pages, because the search engines understand better, so they rank it better, and so on. So which means also it's some sort of race for web designer to annotate it better, because Google has already announced somehow that they would decrease the ranking of pages that do not have any markup at all. So there are different ways of put different formats to embed this markup data in the web pages. JSON-LD is maybe maybe not the most used, but most say pushed for now. Another one was RDFA, and there are also other formats, micro formats and microdata. So it is somehow difficult to get an exact idea of how many websites in the world do use schema.org. It isn't clear. The webpage of schema.org says that I think they say 10 million websites do use schema.org. And I just Googled that and tried to find the number of websites today, and it's over 1 billion. So that would mean that schema.org is only used on 1% of the website. It's very likely a totally outdated information. So the only information I found is this graphic that you can see here. So it shows the evolution of how websites are marked up in the last 3 years. In green, the green line is the percentage of websites that do not have any markup information. And you can see that in 3 years, it has decreased from 55 to something like, it must be 37%. And on the other hand, all the other formats are increasing and increasing steadily. So JSON-LD is the orange line. RDFA is the purple line. So you see that all of these are increasing steadily. So to be honest, I don't so much like this graphic, because it kind of mixes up things of different nature. You have here 2 things: formats and vocabularies. JSON-LD, RDFA, microdata, these are formats. Open Graph, Twitter cards, Darwincore, these are vocabularies. And actually, you can put Darwincore annotations using either JSON-LD or RDFA. But let's forget that. But anyway, the message here is that there is a clear trend that websites and web pages are more and more marked up, and people understand the importance of doing that. So more specifically, what's in schema.org, if you get to their website, you're going to see such a list of types. It's a hierarchy, or you could call that a thesaurus. They have something like more or less 800 types now, plus a lot of properties that go with the types. Now, initially, schema.org was meant to annotate most common things on the web, that is events and movies, shops, items that are for sale, cooking recipes, nutrition facts, whatever. So okay, this is interesting. But if we want to talk about biodiversity, that's our topic here. Well, it's not going to be of much help here. So okay, let's look at what happens in our community, in the biodiversity. When we want to share data, there are lots of different possibilities that can be used, ranging from most simple to most sophisticated one. On the very simple side, you find web pages, which are very maybe basic way of sharing your data with the world. And on the other side, if you continue, you have maybe flat files that you could put for download readable somewhere. If you're a bit more of a techie, you could publish a web API on top of your database. And if you're more in the linked data, semantic web philosophy, you're going to create a knowledge graph that you will publish with following the linked data principles. And you go still further towards the most sophisticated approaches. You have these big integrative initiatives like Gbif and Encyclopedia of Life and ITIC Bio that will gather lots of information from many different sources and make it a consistent and coherent whole. Now, the most sophisticated the approach, the more effort you need to deploy it. And the more sophisticated, the more technical skills you will need. It's going to cost you some maintenance efforts and everything. So not everybody has the manpower to and the skills to push their data to Gbif or just even to publish a web API on top of the database. Now, it occurs that web pages remain maybe the most common way of publishing your data, and let people know about that. Even if this is pretty simple. It's pretty simple and precisely because most of the time, well, web pages are hardly structured data. Okay, it's data for humans, so it hampers integration with other databases, other sources. So since I'm talking about structured, unstructured data on web pages, and I just mentioned schema.org providing a way to structure data, you see where I'm going with this. And well, the nice thing about schema.org is that it is extensible by nature. It's been designed this way. And as a matter of fact, there is an extension of schema.org that we can benefit from, which is called Bioschemas. So Bioschemas is a community initiative with the goal of extending schema.org for the purpose of marking up life science resources on the web. So the main goal is to help search engines understand and index web pages that refer to some life science entities, resources, improve the discoverability and interpretability of the web pages, which is basically the goal of life science, but just in the context of life sciences. So the approach is basically to reuse as much as possible schema.org. The idea is to say whatever is in schema.org, we can try to reuse it as long as it matches our needs in terms of describing things. Now, if it's not sufficient, we can extend schema.org by adding some types, properties, and describing how to use these new terms to describe, to markup life science resources. Another important point is to keep it simple. That is, the point of bioschemas is not to come up with yet another rich domain ontology about different areas in life sciences. The idea is to remain relatively at a high level of abstraction, such that there's going to be consensus. So we will not get into deep details of describing proteins, genes, and taxonomic information, for instance, but we will remain at a level where we are pretty sure there is a consensus. Bioschemas also provides guidelines as to how to mark up the resources more precisely. So it's just not just about types and properties, but it says, okay, that type, an instance of that type should have at least that instance of property with that number of values, or one, or maybe several. It will say which properties are recommended or optional, and so on. And also it will try to link to existing vocabularies or ontologies when they exist and when they are relevant. Last thing, maybe it's to remain flexible. That is, the point is not to have a very strict specification that you have to follow or you're out. Okay, we are on the web, so people do follow the rules or not. And if they do not follow the rules strictly, well, let's try to deal with the data anyway. That's the whole idea. And Bioschemas also has an activity to support software development, and I'll say a short word about that. Okay, so there are quite a lot of terms that have been already tackled in the context of bioschemas. There are terms to denote proteins and genes, data sets, or it's an enrichment of what already exists in schema.org in that case. Some more terms are making their way through the process, like biosample or computational workflow. And there exists a biodiversity group within the bioschemas community that has started by defining two terms that I will describe a bit more in details now, which are taxon and taxonname. So the first type that we have tried to work on is taxon. The idea is that taxonomies are the backbone of most biodiversity databases and portals. So it's important to have a layer, a ground layer on which we can rely to denote taxonomy. So in that page, the color code is that, oh, sorry, I'm looking for my mouse. Yeah, the dark red is for terms that do exist in schema.org, properties or types, and green terms are those that have been added, proposed as an addition by bioschemas. Then you have information about the marginalities. That is, in the first section here, you have the minimum information. That is, it says, if you annotate a web page with the type taxon, at least you should provide a name and a taxonomic rank. Then you have recommended properties and optional properties. Now, if you look at the description of each of the terms, you have the schema.org description that was here. In that case, name is the name of the item. That's the very general description that comes from schema.org. But you also have a bioschemas description, which is some sort of specialization and says, okay, in the context of bioschemas and the taxon term, here is what the name will mean. And in our case, it says that name is going to be used to give the valid or accepted name of the taxon with authorship and data and date if known. So you see this is much more specific. Now, there is quite a, say, balance to find between, like I said, flexibility and constraint, and it's not always easy to find out the right balance. But in the case of the taxonomic rank, we have decided to add a property because we need at least to make sure we understand what's the property that's going to be used here to give the rank. Now, about the values of that rank, it could be a text, it could be URL, or another type, which is a property value. The idea here is to be flexible. So people could say this is a species, so they would give this the string species, or they could give a URI from, ideally from a well-adopted vocabulary. So you could choose URIs from the taxon rank, TDWG ontology, or former TDWG ontology. Maybe you could use URIs from Wikidata, and so on. So here we don't specify a list of terms that you should use, but we leave it open because the idea is that if we say you have to use this list that comes from that reference, well, most likely some people will like it and some won't. And if they don't, well, they will move to something else. So that's this idea of finding the right balance. And arguably, this is not the best solution. I don't know. Okay, so let's see an example. If you're assume you're marking up a web page that denotes some information about the beluga. Well, this is the most simple form of JSON script that you could add in your web page to mark up the page with the taxon type. So you say here, you give the context. So you mean that the terms within this description will be resolved against that namespace. And you say that the page talks about taxon. It has a name, which is the full scientific name with authority, and a taxonomic rank. And here I chose to use only a string as the taxonomic rank. Now I can be a bit more specific and add more information. First thing, this is a taxon, which is the taxon in that case referring to Schema Org namespace, but I could also use other types. Like here I can say, well, that's actually equivalent to the term taxon in the Darwin Core definition. I could use additional values for the taxonomic rank. In that case, I give it as 2 values, a string and a URI from Wikidata, and that's the URI from the species taxonomic rank within Wikidata. The name is the same. I have alternate names, which are basically synonyms or unaccepted or invalid names. Vernacular names, here I use directly the property from Darwincore because, well, we assumed it was not necessary to create another property here. And I can denote the parent taxon here to say, well, that this taxon has the parent is the genus Delphinapterus. Okay. Okay, now what about links to other databases, other portals? You have different ways of doing that. So the first one is to use the same as term, which is standard in schema.org. It links to web pages talking about the same thing. So here I just give the links to the web pages of Doris, WOMS, and IUCN. I could be a bit more specific and give identifiers from remote databases. So in this case, I give an identifier here, which will be presumably my own internal identifier, but I can also give the equivalent ID in WOMS. So here I just say, here is an object that gives the property, this property from Wikidata, which is WOMS ID, and the value here. So again, here I choose to use the Wikidata property. This is not mandatory. You do what you like. But the thing is that if you look at Wikidata, they already have properties for IDs of most well-known biodiversity data sources. So why not reusing them? But again, this is not mandatory. Okay, so far I've been talking about only taxa. Now, what about names? There are some databases and portals that are not registries of taxa, but taxonomic names like IPNI or Zoobank. So in the community, in Bioschemas, we had quite some debates about whether we should make the scientific names more formal in the way we describe them in the markup data. We finally came up with this option of creating a second term, which is TaxonName, so that we can specifically annotate those websites like IPNI, Zoobank, or Microbank. So TaxonName is relatively simple. Basically, it has a name, an author, taxonomic rank, and this is basically it. You could add further information if you like, but you don't need more technically to denote it. And in the taxon specification, we have added a few properties, 2 properties. The first one is scientific name. So it is the equivalent of name, instead that in that case, the object is a taxon name and not just a string. And in the same way, we have alternate name for the synonyms. And we have another one, which is alternate scientific name, which is a list of taxon name instances. So yeah, if you're interested in the whole discussion, it's been a bit verbose. So I pasted here the link to the GitHub issue where we discussed the need of that second term. So here on the left, you have the script that could be added on the page that just mentions the Delphinapterus locus name. That's it. And on the right, you have the annotation, the markup of a web page that talks about the taxon, and you want to link it with the name. So this is a type taxon, and you give it a scientific name, which is an instance of taxon name, and then you can use give the unaccepted names, which are instances of taxon name. Okay. So now you may wonder if okay, these terms are used at all yet or not. So the good news is that there have been some early deployments of those terms. The first one was a work we have done with the National Museum of Natural History in Paris. And so we have started to annotate their species pages. So it amounts to something like 180,000 pages annotated with the terms taxon and taxon names. So basically, these are web pages that existed in the first place, of course, and we just added some further information to embed within the pages a JSON-LD script that describes the content of the page using the taxon and taxon name terms. So you could use the Google Structured Data Testing tool to check that, and if you give it the URL of that page, you could see that the testing tool, data testing tool, will recognize different types, the additional types, the name, which is the full scientific name, alternate name, and if you get down further, you will have the scientific name, alternate scientific names, and so on. Okay, and well, the good thing is that this is not the only one, and we have now a few other early deployments of the terms. The last chronologically, I think, is the Gbif. I just came to know about this one just maybe 10 days ago or so. And it's just been advertised on the Bioschemas website, where we try to keep track of the deployments. And the cool thing with Gbif is that, well, this is such a huge database that whenever they start doing that, well, it's immediately 3 million pages that are annotated with taxon and taxon name terms. So this is awesome, honestly, because it can be a real great incentive for the whole community to do the same thing. Now, just to give a few other examples, Scholia is a website that creates profiles for researchers and organizations, journals, scholarly works based on Wikidata. So it dynamically queries Wikidata to generate web pages, and it actually annotates the pages with the taxon term whenever they talk about some specific species or whatever taxon. Another very different example is PIPA, which is the website of a plant phenotyping experimentation. So the idea is that that website reports experimentations that are done on a plant phenotyping platform, which basically monitors the development of wheat plants, wheat crops. And they annotate the web pages with the taxon and biochem entity. Biochem entity actually represents the plant, the actual plant that is being monitored, and it is related to different instances of taxon to denote the species, infraspecies, varieties, and so on. And another one very different, which is that last one, Opal Surf Casting. This is actually, I think this is an association, I'm not even sure about that reports legislation about, French legislation about leisure sea fishing. So it seems to be maintained by, I don't know, citizens. And the cool thing here is that just with these 5 examples, you can see that we have very different types of websites annotating their pages with the same taxon and taxon name terms. So you can start trying to cross those data just by scraping the information that's here. So the first 2 ones are regular biodiversity sources. The next one is about scientific literature. And next one is more it's phenotyping platform, so it's more in the agronomy and agriculture domain. And the last one is totally different, you know, leisure sea fishing legislation. So it's, yeah, I find it funny that you realize that, okay, just like that, you start having a way of crossing this information. That's the whole point of that. Okay, so now, why do we do early deployments? Why does that matter? The thing is that Schema.org does not create new terms each and every day. You need to show good motivation for that. And one way to show the motivation is to have a community, a strong community that shows its interest into using those new terms by deploying websites that mark up their web pages with the new terms that you propose. And that's the only way for Schema.org to accept new terms, because they can see that, okay, there is some real potential in terms of gathering data and in terms of fostering novel applications, because that's also the point. I mean, we are not just doing that for search engines. We're doing that for fostering the new ideas about how to make applications that would exploit this information. And this is, yeah, kind of the chicken and egg dilemma. I mean, if you want to have novel applications that will use that data, well, you need to publish the data in the first place, even though there is no application yet to deal with it. Okay. Okay, so what are the next steps for the biodiversity activity within Bioschemas? I just mentioned the two first terms that we have defined, taxon names. There are links in those definitions to Darwincore terms. Now, that's just a start. We could, of course, think about many other works, new terms, either new types to be added to Schema.org or new profiles to explain how to use Schema.org to annotate other information. So the information I can think of, but it's not limited. It's about specimen, for instance. So there are lots of works in ABCD, OpenDS, Open Digitized Specimen, MEADS, which is a TDWG community group. Those people have pretty good ideas about what is the vocabulary that you need to describe specimens. So this could be a way to bring ideas in the Bioschemas community and say, hey, here is how we could annotate web pages talking specifically about specimen. Same thing about traits. There are some work on trait ontologies like TPO, trait plan ontology. About occurrences, you have vocabularies like Darwincore occurrences that can be used. And again, this is definitely not a closed list. So I really encourage you to join the group, and if you have ideas about and ideas of what we could do with that, why we would annotate biodiversity data of some type or another, well, just join the community and start the discussion. Okay, so now just this is kind of a summary. Why are we doing this? So having one website marking up their web pages is basically useless. The interest comes when many people do the same. So if we talk about those terms, those biodiversity terms, we now have Gbif annotated the web pages now. So now imagine other big integrative portals do the same, like Encyclopedia of Life and Catalog of Life, collections portals like iDigBio and Disco. But also in independent museum collections. There are thousands of museums that have their own website where they show their collections. Think about literature websites like Biodiversity Heritage Library or Plazi. There are lots of citizen science platforms and independent institutions, associations like the one I showed just before. Okay, all of these are potential candidates for doing that. And as soon as you have such critical mass of web pages annotated with the same terms, well, you start having a huge potential for developing new applications. And I talked maybe a lot about search engines here, but search engines are just one of the applications. You can think of developing registries that will try to make some sort of cartography of the biodiversity web, aggregators that will scrap pages from lots of different websites, totally different ones, and I don't know, create some repurposed data and come up with clever ideas to use this information, and then come up with nice applications that do that. Think about all the gray literature. We mean gray literature. You know, these are all the reports and CSV files that are just stored on your laptop that you never publish anywhere. Well, that's a way of publishing that. I mean, you can put this information on a website, make it downloadable, and just annotate the page and say, okay, that thing talks about this taxon and this taxon, and what else? And then maybe your information will become useful for somebody. You don't know. Okay, so a few takeaways. I think you've got my point now. Marking up web pages is a way of increasing the visibility and discoverability of your web pages and overall of your data. it is relatively inexpensive. Most of the time, when you have a website, you have a process that reads data from your database and generates an HTML page where it's not much work to continue the process, and just in addition to the HTML code, you just add a piece of JSON script and with a few markup information. That's pretty easy, and it's not going to be costly, or it's not going to require much computing power. Marking on web pages is also, that's the idea I've tried to convey, is a way to connect pieces of data that so far are not connected. So think about the gray literature. Now, it is of course not a magic bullet. There are lots of issues that will not be solved because you're marking up your web pages. If you have discrepancies in the way names are used, people disagree about the names. Well, they still disagree whenever this is published on their web page using markup data. If people sometimes don't comply with the nomenclatural rules, well, same thing. You're going to have troubles aligning words, scientific names that do not respect the same nomenclature rules. Okay, so again, this doesn't solve any of these issues, but these are long-lasting issues. I mentioned also the case of taxonomic ranks, but there are other issues like that. So for now, we have proposed that anybody could use any terms of their choice to denote taxonomic ranks, URIs, string, whatever. But that means also it's more difficult to cross the data, to make sure the data talks about the same thing. So again, there is work to do, but still, it is quite, it can really spur new use cases and new applications. And maybe finally, just a word about the search engines again. So we often blame search engines because they are like pump up our data and make money out of it. Well, this is right somehow. But at the same time, we can consider that we can benefit from that, what they are doing. Search engines are good at doing one thing: crawl the web. And they're almost the only ones to be capable of doing that because they have huge infrastructures optimized to do that. So what if we can take advantage of that and make them do the job for us? That is, if they can scrape the web and have leveraged terms that are in Schema.org that we could have endorsed by Schema.org, like TaxonName, specimen, occurrences, traits, whatever, then we can use those search engines as an entry point for some further data integration task. We can also think about specialized search engines. So we now have the example of Google search engine, Google dataset search engine, which can be a very good entry point to find data sets talking about some biodiversity domain. But in the end, we can think of new applications like a species search engine, which would be specifically focused on this kind of markup data and so on. So you see, I think the scope is pretty large about what we can do with that, but now it needs that the community adopts the practice in a general manner. And well, thank you for your attention. And I think we will have time to take a few questions.
Thank you, Franck. Really, thank you very much for your interesting talk. So there are already a couple of questions in the Google Doc. I don't know, maybe you can stop screen sharing so that we can see each other a bit better. So for those who have questions, please feel free to raise your virtual hand or put your questions in the Google Doc. But I'm happy if you want to frame your question by yourself. I think this usually makes more sense if you are here. So the first question was, is there any plan to adapt Gbif and catalog of life websites with microdata? But you already showed some examples.
So for Gbif, this is done. For catalog of life, I don't know if there are some people here from catalog of life, maybe they could answer.
Can they turn their mics on now?
No,
I see.
maybe not.
Maybe not. Maybe not. So this remains, should be answered afterwards. Is there a document documenting the mapping with Darwincore?
So the mapping with Darwincore, yeah, it's on the specification of the taxon type and taxon name types. For now, well, the only reuse that we have made of Darwincore is the vernacular name, I think, yes, which doesn't mean you cannot use other properties. I mean, when you're marking up your data, your pages, you should try to comply with the rules that are provided in the specification of the terms, but that remains the semantic web. It's open, so you can still add some further annotation using Darwincore or even other vocabulary that you like. Now, I'm not sure I'm answering correctly the answer, the question. If the question is more about, is there a way to translate bioschemas markup into Darwincore? No, we have not done that yet. But to be honest, this is no big deal. Like I said, Bioschemas tries to remain a pretty high level, so it doesn't get into much detail. So basically, the taxon type will be the equivalent of the taxon term in Darwincore. Well, there's not going to be any equivalent, I think, of taxon name. There would be an equivalent in the TDWG ontologies that had a concept for taxon name.
Okay, thank you. Well, the question was rather short, so I don't know whether this was answered by your answer now. The next comment is by Steve, but this is rather long. I don't know, Steve, maybe you would like to read this by your own?
You sort of already answered it, so I don't know if you want to spend time on it. I guess I have experimented with this sort of thing in the past, and nobody ever seems to make use of it. But I guess part of your point is just that you need to have fairly wide adoption before people will take the time to develop the scraping tools and things like that. I mean, Google basically has never paid any attention to anything that I've ever done, but maybe Google is the wrong audience.
Yeah, but by the way, Bioschemas tries to support the development of some tools, and in particular, tools that would help you mark up your pages, that is, so that you don't have to write the Json code by hand. And on the other hand, tools that help you scrape the data from web pages. So there is at least one of them I can remember, which is Bmuse. You will find the link on the Bioschemas website. It makes the rendering of a web page and just extracts the information and translate this into entryples file. And you can do that with thousands of URLs that you give in a list or just a sitemap. So yeah, there are things that can help you to do that. Maybe Alistair is online. Maybe you have other pointers to tools that can be used to do that, Alistair?
I've just put a pointer to Bemuse in the chat here. Yeah, so I mean, really the key here is about sort of coming up with the innovative apps that are going to use the data that's available. So we've got a fairly robust scraper there now that can do page-directed scraping. And we just need people to sort of think, right, I've got this data over here, this data over there. I want it to be constantly updated.
People will really make new applications exploiting it.
Yeah, and more than willing to help people do that.
Okay, thank you. The next question is by Debbie, but her connection is right unstable. I don't know whether you want to speak up. Otherwise, I will simply read the question. It's Frank, can we already share people information if we have PIDs for them?
I'm not sure I understand the question.
I'll try, Frank. All I'm saying is you were talking about different properties, taxon, TaxonName, other people. If we're starting to gather and there's momentum around identifiers, Wikidata, Q numbers, or ORCID IDs for people. Can we, if we have that data, mark it up in a bioschema?
Yes. Yeah, absolutely. One thing that I have not shown in the examples is that you can add an ID for any kind of thing that you mark up in your piece of JSON LD, and it's actually recommended to do that so that we are sure not to create blank notes all the time. So you could use IDs for your taxa, for people, like an orc ID is pretty good. So yes, definitely.
Thank you. The next comment or question was by Anton van de Putte. I don't know whether I spelled it in the correct way. You would like to speak up?
Yes, thank you. Hi, I'm Anton van der Putte. I manage the SCAR Antarctic Biodiversity Portal, which is a node for Gbif and OBIS. And so in the polar community, the general data community, we've been discussing a lot the use of schema.org to make metadata better discoverable. And I think within the ocean best practices communities, there have been discussions about using that as well and the semantics behind that. Have you been in touch with them discussing these things? Because I think it's good that there's these initiatives, but I also think it's good to talk because it's good if they can convert at some point. And then maybe it's good to talk sooner than later.
No, it is an initiative. I don't know. I've not been in touch with those people. But yeah, like I said, the community is very open. So if you guys want to join the biodiversity group within Bioschemas, and if you want to propose, just start discussions actually.
Yeah, but yeah, it might
see where
be
it goes.
To invite you to one of the polar group. It might be good that you give a presentation there as well, because it might give a different perspective for us group as well.
Sure.
But thank you, very interesting presentation.
You're welcome.
Frank, can you put a note somewhere where people can contact you or your group? I don't know, in the chat maybe, or in the Google Doc later on, so that that they don't have to dig for your email address or any contact detail. That would be great.
Yeah, just pasting my email address here.
Then there's a question. It is very common. It is very common people share data using data repositories like Figshare and Riot. They already use schema.org to annotate data sets. But is there any way to use bioschemas within repos? So maybe also sharing a JSON file?
So I don't know those repositories, Figshare and Riot. So I just double read they already use schema.org to annotate data sets. Is there any way to use bioschemas within repositories? So I'm not sure how to understand the question, but the thing is you can use multiple annotations at the time. That is, you could annotate a page saying this is a data set. So you use the regular term schema.org/dataset and say that data set is about that type of entity, which is an instance of that and that and that. So here you can connect that to bioschemas terms. I'm not sure if that answers the question, honestly. About sharing a JSON file, well, that can be done. This is a possibility that you have. You could put in your sitemap, for instance, a direct link to markup file, so a JSON LD file. That works, although this is not, as far as I have seen, this is not so much recommended as good practices. At least when you talk to Google, they say that they prefer when the markup data is embedded within the page so that they can really connect things together. But again, that's what Google says.
Thanks. Then there's just a comment, but I will read it out here as well. We are using bioschemas in our work in the Discourse Synthesis Plus Specimen Data Refinery for describing and registering the workflows and for describing the digital specimen. I think that's a good way to go here. Then there's a question by Franck Michel. Is it possible to mix JSON LD and microdata in the same document? And further on, JSON LD is relevant for indexing interoperability, while microdata can help to parse documents coming from HTML websites?
Okay, so technically, yes, it's always possible to mix different formats to annotate your web page. You can use microdata, RDFA, JSON-LD, all in the same page. And that's often what happens, by the way, because, well, anyway. Now, is it a good practice? I'm not so sure. Again, the trend seems to be to try as much as possible to split things. That is to avoid mixing markup information within the HTML code. That's what's going to happen with RDFA, for instance. But yeah, again, this is just a recommendation. Also, yeah, Bioschemas recommends JSON-LD. That's a recommendation, or I would say a strong recommendation. But technically, again, this is not mandatory. The thing is, I don't know what happens if you mix formats. What do search engines do with that? Can they connect things if you talk about the same terms but in different formats? Maybe they can. I don't know.
Thanks. There's a question by Zach Maritim. I don't know. You would like to phrase your question by yourself? Okay, maybe not. So how will this optimize spatial search, for example, for occurrence or geographic scope?
I will not try to fool you. I don't know. This is definitely not my domain. I'm not an expert of special data. So yeah, honestly, I don't have the answer. Sorry about that.
So there was a comment by Matt Yoda. I don't know whether this answers the question. GeoJSON hooks?
Yeah, GeoJSON is a JSON format. It's not JSON-LD, but maybe you can mix it with some JSON-LD. I'm not sure. But again, yeah, I'm not the right person to answer this question. I'm sorry.
It's fine. You cannot answer everything.
I can see the next one. Yeah.
How difficult or easy is it to add the JSON-LD into WordPress and Blogger?
Yeah, that's a question we had at the TDWG conference. So basically, whether this is Bioschemas or Schema.org or anything else, that doesn't make a big difference. So when it comes to content management systems like WordPress, Drupal, usually you have plugins that help you mark up the web pages. So they are pre-wired with forms that will help you fill in traditional information like organization, people, maybe the products that you sell. If it is a search SEO plugin like search engine optimization. Now, these plugins usually give you the ability to add other types of markup information beyond those that are pre-wired. And you can use anything within Schema.org or Bioschema. So my answer is that there is no specific plugin so far to help you put Bioschemas annotation within a WordPress page. But you could use regular plugins to do that, though, even though it's going to be a bit more manual, probably. In the future, I think having maybe the development of a specific plugin for WordPress or Drupal would be probably very good to help people do that and avoid technicalities, for sure.
Okay, for the next comment, I think we will simply collect some links and background information for newcomers to this topic and share this after the session. There are already some answers from the question from Stan, which is, are there other examples of standard organization interacting or influencing Schema.org or Bioschemas? And how should TDWG interact with Schema.org?
Well, standard organizations, yeah, I don't know what it means really. So if this is about like organizations like, I don't know, TDWG or Gbif, I don't know if there are direct links. I'm not sure, honestly. But Bioschemas is a relay. So there are in Bioschemas, there are people from, I guess, Gbif, from TDWG. So it is a relay, and that's the right interface to talk with schema.org people. That's what happens usually. But there might be other direct exchanges between those that I'm not aware of.
Okay.
By the way, just as an information, there has been something that was available on Google. When you Google the name of a species, you may have a rich snippet that links to Encyclopedia of Life, and for some time it was giving directly the traits of that species. And I have always wondered how that was possible, how that did happen. So I suspect that at some point there were some contact between Google directly or schema.org and Encyclopedia of Life, although I didn't have a confirmation of that. But yeah, maybe that was a one-shot try to experiment this kind of thing.
Okay, thank you very much. Unfortunately, it's also already 6 o'clock, at least in Germany. I think it's, you have other times on your clock, on your computer. So our webinar is over to today. Thank you very much, Franck, for your talk, for answering all those different questions. We will, of course, make those information available afterwards, and the session was recorded or is still recorded, and we will also make this available and announce this on the TDWG website. So thank you all for joining the session today, and there will be more webinars coming, so stay tuned. Thank you.